Okay, today we are looking at how to solve absolute value problems. When it is an equation, as in the absolute value of 5x plus 10 equals 45, we always have to check the answers. And make sure when you check, you're always putting your answer back into the absolute value equation and making sure that it works. So, if I give you the absolute value of 5x plus 10 equals 45, we need to remember that an absolute value talks about a distance. We can be 45 units one way, or we can be 45 units the other way. And we show this by making 45 negative in our second case. All right, so we solve our equation, and we get 5x is equal to 35 by subtracting 10. And by dividing by 5, we get x is 7. This is for our first case. For our second case, when we subtract 10, we get 5x is equal to negative 55. And we get then x is negative 11. So when we check, and you need to show me your check, you can't just do it in your head, we start by saying, well, we start with the absolute value of 5x plus 10. And that's supposed to equal 45. And we insert the 7. And we want to see if we're going to get 45. Well, we get still within the absolute value. We carry this absolute value sign down to the absolute value of 45, which is, in fact, 45. And so it does work. If it didn't work, then 7 would not be an answer. But currently, because the check works, 7 is an answer. All right, so we try x is equal to negative 11. And we start with our absolute value equation that we were given at the very beginning. And we write our second case, or we use our second case's answer of negative 11. And we get negative 55 plus 10, which is negative 45 in absolute value, which truly is 45 also. And so it checks. And so we know then that there are two answers, 7 and a negative 11. Now sometimes we'll only get one answer, and sometimes none of the answers will work. So let's look at this next one. We get 2x plus 12 in absolute value, and the answer is 4x. So our two cases will be the first one written as it exists, and the second one is going to be 2x plus 12 equals negative 4x. All we're doing is putting a negative sign on to our answer. Solving by moving the 2x to the right gives me 12 is equal to 2x because I'm subtracting, which means x is equal to 6. There is one possible answer. When we move the 2x again by subtracting, on our second case, we get 12 is equal to negative 6x, and so x is equal to negative 2. All right, these are our two possible cases, and now we're going to check. So when I check the first one, I start with absolute value of 2, and I'm inserting 6. And then I'm going to say plus 12. And that has to equal 4 times 6. So we're putting the 6 now in two places. First one right here, and the second one right here. All right, this is going to be 12 plus 12 in absolute value of 24, which 24 is equal to 24. So we know that this case works. Then we do the second check, and I'm running out of space, so I'm going to kind of go down. But we're going to insert negative 2. And so now we're going to say the absolute value of 2 times negative 2 plus 12 has to equal 4 times negative 2. Remember, we're putting this negative 2 in wherever the x appears, and it's going to appear in two places, here and here. So we get the absolute value of negative 4 plus 12 has to equal negative 8. Well, we're going to get the absolute value of 8, which is 8. But does 8 equal negative 8? And the answer is no. So that means this case doesn't work, and our only answer is 6. And so we indicate that it doesn't work by crossing out our answer the way I did. And that shows that this answer of x equals 6 is the only one that works. Okay, so then we go down to inequalities. We don't need to check, but you do have to have a graph. So we're talking about a line graph. Well, again, we're going to want to do our two cases. Now, this is greater than, which means it's going to be an or statement. And so in our head, we need to know that our graph is going to be going opposite from 2 starting points. So we do our 2 cases the way we did in the earlier problems. We're going to set 4x plus 5 greater than 13. But our second case is going to say 4x plus 5 is, we flip the direction of the inequality, and we put a negative sign because we want to go greater than 13 or less than negative 13. So then we solve. We say 4x, we subtract 5, so that's going to be greater than 8, which means x is greater than 2. And over here we get 4x is less than negative 18, which means x is less than negative 18/4, which is the same thing as negative 9/2. So we're going to put these values in the right order. Negative 9/2 is here, positive 2 is here. Both of these are open because they don't have an equality sign in their they don't have an equal sign in their inequality. And then greater than 2 means values that get big, and so we think about going to the right. Less than negative 9/2 means we're going more negative, and so our arrow goes to the left. And remember, we said that this was an or statement, and so basically we knew that our arrows had to go away from each other. Okay, the next one. If I give you the absolute value of x plus 2 is less than 6, our cases are going to be x plus 2 less than 6, and, because this is going to be an and statement, we learned that in the last section, x plus 2 is greater than negative 6. And so we're going to say here x is less than 4 and x is greater than negative 8. And so here's negative 8 and here's positive 4. Open intervals again because there's no equal sign in our inequality. Greater than negative 8 and less than positive 4 means that we are just going to go in towards each other. And that's what that graph looks like. Okay, so give the homework a try, and it should be review from last year.